This is my geometry course. Today we're going to prepare for test number 2. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As I mentioned when we prepared for test number 1, there are some subjects where you can study an hour the night before and ace the test. But math doesn't work that way. With mathematics, you need at least 2 days to prepare for an exam. But it doesn't matter how many times you tell students to study for a test, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice exam right now together. And I'm going to give you a practice exam for homework. And these exams are going to do 2 things. Like I said, they're going to force you to do some studying for the test. But number 2, they're going to familiarize yourself with the actual test itself, so you can't take the test and claim that I tricked you. Now, I want you to understand that these practice tests are not optional. They are required. You must do these practice tests before you take the actual test. So that said, let's get started with practice test version 1. Like all my tests, there are 25 problems, and each problem is worth 4 points. Now, as we go through this practice test that we're going to do right now together, I want you to try these problems on your own before you watch me do them. If you get stuck, that's okay. But I want you to give an honest attempt to do them yourself, because your mind is going to be much more engaged if you actually think about the problem before you watch me do it. So that said, go ahead and try problem number 1, and when you come back, we'll do it together. All right, we're back. So this triangle is an equilateral triangle because the side lengths are all the same. So we learned a theorem called the equilateral triangle theorem that says that if a triangle is an equilateral triangle, then the triangle must be equiangular. Now, what does that mean? It means all the angles are congruent. But we learned another theorem called the equiangular triangle theorem that says if a triangle is equiangular, then the measure of each triangle is 60 degrees. Now, that's a lot of fancy talk, but it's just common sense. We know from the triangle sum theorem that all the angles have to add up to 180, right? And we know that all the angles must be the same. That's kind of common sense, right? Because it's an equilateral triangle, so it must be equiangular. So you can just use basic logic to figure out that 2y must be equal to 60 degrees. Each angle must be equal to 60 degrees. Divide both sides by 2, and we have 30. Y is equal to 30. And you don't have to write a degree sign. Some teachers require a degree sign for the y. If you're finding this entire angle, I would require a degree symbol, but because it's a variable within there, I don't really care. So if you got that answer, good job. Go ahead and try number 2, and when you come back, we'll do it together. All right, we're back. So we have a theorem called the isosceles triangle theorem. It says that if 2 sides of a triangle are congruent, then the angles opposite those sides must be congruent. We're not going to use that because we don't know that the sides are congruent. What we know is that the angles here are congruent. So we're going to use the isosceles triangle converse theorem. That says that if there are 2 angles in a triangle that are congruent, and remember those double arcs, they're both double arcs, that means they're the same angle. If 2 angles in a triangle are congruent, then that means the opposite sides must be congruent. So this side must be congruent to this side. Now, you don't have to think about this with this degree of detail. You just have to recognize it's an isosceles triangle, which is pretty easy to do, and just write your equation and solve it very quickly. So I'm going to be going a lot slower when we do this practice exam because I'm explaining every step. You don't have to do that when you take the test, so just be aware of that. Okay, so we're going to subtract b from both sides, subtract 5 from both sides, so on and so forth, and there you go. b is equal to 15. So if you got that one right, good job. On to number 3. It says, find x and state the theorem or postulate used. You do not have to write a 2-column proof, but you must show the equation used to find x. So go ahead and try number 3. If you can do it, and when you come back, we'll do it together. All right, we're back. So it's very important to notice these arrows here. These arrows mean that those two lines are parallel. If those lines are parallel, that means that we can use, well, we learned 1 postulate and 3 theorems. So one of the theorems that we learned was the alternate exterior angles theorem. That tells you that if you have 2 lines that are parallel and a transversal that goes through them, alternate exterior angles must be congruent. Now, these are exterior because they're on the exterior of the parallel lines, and they're called alternate because one is on the left of the transversal being the blue, and the other one is on the right, the other side. That's why they're called alternate exterior angles. So we can just set those equal to each other. Again, you don't have to talk about it in this amount of detail when you actually do the test. You just have to write the equation and solve it. So add 4 to both sides, divide both sides by 3, and that would be 48. So which theorem did we use? I probably should have written the theorem first. So you can abbreviate alternate exterior angles theorem. So that's part of the answer, so I want you to rectangle that too. So if you got that one right, good job. Okay, on to number 4. Go ahead and try number 4, and when you come back, we'll do it together. All right, we're back. Is the following statement true or false? The triangle sum theorem can only be used with right triangles. So the triangle sum theorem tells us that the measures of all angles of a triangle, they always add up to 180 degrees. If you add up the measures of all 3 angles in any triangle, the sum is always 180 degrees. But that works with any triangle, not just right triangles. For example, you might have a triangle that looks like this. That's not a right triangle. But if you add up all the angles, it's going to be 180 degrees. So that statement is false. So if you got that one right, good job. And by the way, if you didn't remember what the triangle sum theorem is, then, well, you have no hope of doing that problem. So what does that teach us? It teaches us that you have to actually go back and look at the theorems and the postulates that we've learned. That's going to take some effort to go back and look at those theorems and postulates and so on and so forth, definitions and memorize those, but you have to do it. It's just part of studying for exams. So now we're going to go to part 2, name the following angle pair. So notice that these lines don't necessarily have to be parallel in order for us to come up with a name for that angle pair. This is still a transversal, even though those other lines are not really parallel. And these angles are on the interior of the 2 lines that the transversal is going through, but they're on the same side. So we say that those are consecutive interior angles. Consecutive interior angles. So if you got that one right, good job. Now again, if you're rusty on this stuff, that's okay. Again, this is kind of motivating you to figure out what exactly you need to know. Do you need to know these things for the test? Yes, you do. So if you're expecting to just remember this stuff without going back over the material, well, now you know that's not going to work. All right? Okay, so on to number 5. If the tire shop is halfway between the dealership and the gas station, what are the coordinates of the gas station? So see if you can do this one, and when you come back, We'll attempt it together. All right, we're back. So apparently there's a gas station up here, and the tire shop is in between them. So the first thing that we need to do is I'm going to write the coordinates. So we have 1, 2, 3, 4, 5, and then 1, 2, 3. So that's -5, 3. And we have 1, 2, 3 down. So that's going to be 0, -3. Sorry, I should write that better. And so now this here is the midpoint. So the midpoint formula is like so. If you want to find the midpoint of two other points, then you add the x values and divide by 2, and that gives you the x coordinate of the midpoint. And if you want to find the y coordinate of the midpoint, you add the y values and divide by 2. So that's the formula that we learned from the midpoint. So that must be equal to -5, 3. Why is that? Well, because we're told that the tire shop is halfway between the dealership and the gas station. So that means that the tire shop is the midpoint. Remember, the gas station is up here, right? Somewhere up here. So the tire shop is the midpoint, so that's why I set this equation equal to this. So what that means is that the x-coordinate of the midpoint must be equal to -5, and put a little squiggly there to show that we're going to a different equation. The y-coordinate of the midpoint is equal to 3. Now, we also know other information here. We know the x-coordinate of one of the points is 0. You see that down there? That's 0. That's the x-coordinate. So we can say 0 plus x2, and it doesn't really matter which one you plug in. You can plug in to x2 or x1. So that's 0, and then we can solve this equation for x2. So x2 over 2 is equal to -5. Multiply both sides by 2, and we get x2 is equal to -10. So that's the x value of the point up here, which is the what is that? That's the gas station up there. So now we know the y value of one of the points too. Again, we're not talking about the midpoint. That's the tire shop. We're talking about the points around the tire shop. We know the y value is -3. All right, so now we just solve that equation. Multiply both sides by 2. And we get y1, and we can just change that to -3. Y plus -3 is the same thing as y minus 3. Well, maybe I should just do that. Okay, you can do this as quickly as you want to do it. You don't have to do every step that I'm doing here. But you do have to show your work. Okay, so now we know that the coordinates of the gas station up here, the coordinates are going to be -10 and 9. And you may want to check just to make sure if that makes sense. So let's think about this. It's -10, 9. So that means we go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go 9 up, which is 1, 2, 3, 4, 5 is about here. So that makes sense, right? It's got to be somewhere up here. So if it turns out to be over here or over here, you know you did something wrong. Again, the tire shop is halfway between the gas station and the car dealership. Okay, so if you got that one right, good job. You can do plenty of practice problems for that. Again, a lot of students are going to look at this and they're going to say, well, that kind of made sense, but I don't know if I have enough, I don't know if I can do it on the test. go back to the problems and do more practice problems. You've got homework assignments, you've got the in-class work. You can do plenty of those problems so that you're going to be confident for the test. Now, I know that's going to be a lot of work. You're thinking, I don't want to do that. Well, I know, but that's how you study for a math exam. It's not going to work otherwise. Okay, let's try number 6. Go ahead and attempt number 6, and when you come back, we'll do it together. All right, we're back. This is a right triangle, which means that you can use the Pythagorean theorem. Remember, that's the theorem that says that if you have a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Now, the hypotenuse is the longest side, the side that's opposite the right angle. So now we can plug in numbers. So it doesn't matter what letter you plug in x for. You can plug in x here or here. It doesn't really make any difference. But remember, only 3 root 2 can be c. So x squared plus 3 squared is equal to 3 root 2 squared. So just to be clear, that went there, and this went here, and that number went there. All right? Okay, so then we have x squared plus 9, and here we have 3 root 2 times 3 root 2. That's what square means, right? So 3 times 3 is 9, and then root 2 times root 2. Well, remember, we learned in my beginning algebra course that when you multiply two roots, it just gets rid of the root if the base is the same. Another way to think about it is root 2 times root 2 is root 2 times 2. You just multiply those in. And so then we get 9 times root 4. And you don't have to show all these steps. In fact, you don't have to show any of these steps. You have to show that you're plugging in the numbers. So you have to show that step. And then you have to show the answer pretty much. But this is just for your benefit here. So now we have x squared plus 9 is equal to 9 times, what is the square root of 4? So what number multiplied by itself is equal to 4? What number multiplied by itself is equal to 4? And the answer is 2, because 2 times itself is 4. 2 times 2 is 4. So now we have x squared plus 9 is equal to 9 times 2, which is 18. And then we can subtract 9 from both sides. And then we want to, because at this point we found x squared, right? But we don't want x squared. We want x. So we're going to square root both sides. And remember, when you square root both sides, you got to write a plus or minus. That's probably one of the most common mistakes that students make in the math curriculum. So now that gets rid of the square, and we have plus or minus 3. But here's the thing, you cannot have a negative side length. There's no such thing as a negative side length. So we can just forget the plus or minus and say 3. So x is equal to 3. So if you got that one right, good job. Again, if you're a little rusty, that's okay. The purpose of this test is to get you ready for test number 2. All right, let's try number 7. Go on attempt number 7, and when you come back, we'll do it together. All right, we're back. So we need to use the triangle sum theorem. That tells us that the measures of all angles in a triangle, they always add up to 180 degrees. The sum is always 180 degrees. So 9y plus 21 added to 7y minus 4 added to 4y plus 3 must be equal to 180 degrees. And if you add all the y's, 9y plus 7y is 16y, 16y plus 4y is 20y. You can do that all in one step. That's fine. 21 minus 4 is 17, and 17 plus 3 is 20. So we added all the like terms, all the y's we added together, and all the regular numbers we added together. And now we're going to subtract 20 from both sides. Now we're going to divide both sides by 20, and we get 8. So if you got 8 for y, good job. Okay, on to number 8. Go ahead and attempt number 8, and when you come back, we'll do it together. So in order to do this problem, we need the angle bisector converse theorem. So what that tells us is if a point in the interior of an angle is equidistant from the sides of the angle, and the reason we know it's equidistant is because we have these double tick marks, right? That means those lengths are the same, but these right angles mean that this distance from here to here is the shortest distance. So that these represent the distance from that point to the sides of the triangle. So the theorem tells us that if a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the ray that bisects that angle. So that means that if this angle here is 45, then this angle must be 45 degrees also. So 45 degrees must be equal to 20 plus 5m. But just realize that we need these double tick marks, and we also need these right angles. If you don't have these right angles, then those lines don't represent the shortest distance from the point to the sides of the angle. So subtract 20 from both sides, divide both sides by 5, and we see m must be equal to 5. So if you got that one right, good job. Okay, in problem numbers 9 through 12, determine if the triangles are congruent. If they are congruent, write a proper congruence statement and the triangle postulate or theorem that proves that they are congruent. And we don't have to use a 2-column proof here. So we're just writing the answer quickly. So go ahead and try number 9, and when you come back, we'll do it together. All right, we're back. So we learned 3 triangle congruence postulates and 1 triangle congruence theorem. And here are those 3 postulates and the 1 theorem. We also learned the hypotenuse leg theorem. That only applies to right triangles. So let's see which one of these we're going to use, if any. So we see that this angle is congruent to this angle, and we see that this side is congruent to this side because they have the same length, right? And we see that this angle is congruent to this angle, right? So because 20, the side that we know is congruent, the blue, that's between the angles. It's between 42 and the double arc, right? So what that means is we're going to use ASA, the angle side angle triangle congruence postulate. And so we know that the triangles are congruent because if you have 2 angles in one triangle that are congruent to 2 corresponding angles in another triangle, and the side between those triangles are congruent, that information alone proves that the 2 triangles are congruent. All right, so now we're going to write a triangle congruence statement. So I'm going to say triangle ABC is congruent to triangle. So we started at A, that's the 42-degree angle, so we have to start at D, the 42-degree angle in the other triangle. And then we went from A to B, which is the yellow, so we have to go the purple to the yellow, so that would be E, and then F. If you don't write those letters in the right order, then your congruent statement's going to be wrong. Now, why did I start with A? Well, I just started with A because it's alphabetical, but it doesn't really matter which letter you start with, as long as the letters here correspond to the letters here. They're in the right order. So if you got that one right, good job. So part 2 here, if you haven't already tried part 2, go ahead and attempt that one. And when you come back, we'll do it together. All right, we're back. So we know that this side is congruent to this side, and we know that this side is congruent to this side, right? We also know that this angle here is congruent to this angle. Now, don't act like that's some crazy piece of information there. You know that. That's the vertical angles theorem. If you have two lines that intersect, then angles across from each other, called opposite angles, or you can call them, what we named them, vertical angles, they must be congruent. So we know that those orange angles are congruent. So we have a side, then a side next to it, and then an angle that is not between the two sides, but over here. So what that would be is SSA. It's the SSA congruence postulate. But there's a problem. There is no SSA congruence postulate. So the answer to this problem is not enough information. The triangles look like they're congruent, but we don't really know. And it turns out that you could actually tell, you could know for sure if they're congruent, but the most important thing is to learn the postulates and theorems that we learned so far. So based on what we learned so far, we're going to say not enough information. We can't say that they're not congruent because it's possible that they are not, or it's possible that they are congruent, but we don't know based on the postulates and theorems that we've learned so far. So if you got that one right, good job. Again, there is no SSA triangle congruence postulate. So try number 10. Again, you want to figure out if they're congruent, and then name the congruence postulate or theorem that you use to figure that out. Then write a triangle congruence statement. And by the way, you can abbreviate your triangle congruence and theorems and postulates. That's okay. So try number 10, part 1, and when you come back, we'll do it together. All right, we're back. So we know that this angle is congruent to this angle, and we know that this angle is congruent to this angle, and we know that this side is congruent to this side. So we have two angles and a side that is not between the two angles. Okay, if the side were between the two angles, we'd use ASA like we did in this problem up here. 20 is between 42 and the double arc, but here this side is not between the angles. So for this problem, we're going to use AAS, because we have a side, or excuse me, we have an angle, then we have an angle right next to it, and then we have a side that's not in between them. And that is an actual theorem. Remember, there's 3 postulates in one theorem for triangle congruence, not including the hypotenuse leg. The hypotenuse leg is a theorem also, but I'm talking about the first 4. So now we can say that triangle ABC, and I'm just going to choose to write the letters in alphabetical order. ABC is congruent to, now I started with A, the 88-degree angle, right? So I have to start with D over here. And then we went from the 88-degree angle to, we went down the triple arc. So I'm going to go down the triple arc over here to get to F. It's going to be DF, and then E. So here it wasn't alphabetical. So don't always expect the answer to be alphabetical. Okay, so if you got that one right, good job. If you're rusty on these, again, that's okay. That's the purpose of these practice tests, to get your mind working and to understand what exactly you need to know. Part 2. Go ahead and try part 2. When you come back, we'll do it together. All right, we're back. So we know that this side is congruent to this side, and we know that this side is congruent to this side, and yes, that's right, we know that this side is congruent on both triangles. Why? Because the triangles are up against each other. Obviously, the yellow side has to be the same in both triangles. So what that is SSS, side, 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 triangle congruence postulate. So let's write that abbreviation. That tells us the postulate that we're using. And I'm going to make a separation there. We can say triangle ABC is congruent to triangle. Now we started over here. That would be, sometimes it's kind of hard to tell, but A is between the 42 and the 63 side. So over here, B is between the 42 and the 63 side. So we start with B, and then we went from A and then across the diagonal there. So we're going to go from B across to A in the other triangle. So BA, and then of course D. All right, so if you got that one right, good job. On to problem 11. So go ahead and try part 1. Again, we're trying to figure out if the triangles are congruent, and you need to write the congruence postulate or theorem that you use. So try part 1. When you come back, we'll do it together. All right, we're back. So we know that this side is congruent to this side because they have that tick mark, right? We also know that this angle is congruent to this angle. So that's the vertical angles theorem. Remember, again, if you have two lines that intersect, these angles here are congruent. That's the vertical angles theorem. But that's all we know. Sometimes we get a problem where these lines here are parallel. In that case, we could use the alternate interior angles theorem to find these angles here, but we don't know that those lines are parallel. So we really don't have enough information. So you can say not enough information. So if you got that one right, good job. All right, go ahead and try part 2. When you come back, we'll do it together. All right, we're back. So we're told that x equals 9, so we need to plug that in. So I'm going to rewrite these triangles. And I'm going to plug in 9 for x here. Negative 2 times 9 is negative 18. Negative 18 plus 91, that would be 73 degrees. And you can use a calculator for that, that's okay. And I'm going to draw the other triangle. Your triangles don't have to be exact. Plug in 9 here, 8 times 9 is 72 degrees. So we could use the AAS theorem for triangle congruence, but the problem is these two angles are not the same measure, so it's not going to work. Again, AAS. You're just moving along the triangle as you state those. So we can actually say that they're not congruent. In this example, we actually know for sure that they're not congruent because there's no way that it could be true that that situation would lead to congruent triangles. So if you got that one right, good job. All right, so again, figure out if these triangles are congruent. and write the postulate or theorem used. When you come back, we'll do it together. All right, we're back. So we know that this side is congruent to this side, and we know that this side is congruent to this side, but that's the only information we have. They look like right triangles, so the problem is trying to fool you. It's trying to make you think that you can use the hypotenuse leg theorem. If the hypotenuse and one of the legs of these triangles, if they're congruent, then that proves that the triangles are congruent, but we don't know that these are right triangles. They look like right triangles, but we don't know if they are. How is it that we don't know that they're right triangles? Well, because we don't have a square right there, you see. I just wrote those green squares in. We didn't have those. So just because they look like right triangles doesn't mean that we know that they are, so there's not enough information. So if you got that one right, good job. Okay, on to number 13. Find x, y, a, b, c, d, and m. So the first thing that we can do is we can say we have two lines that are intersecting, and so vertical angles are congruent. So these are vertical angles because they're across from each other, so y must be 93 degrees. If this is 93 degrees and this angle here, its measure must be 93 degrees too. So y is equal to 93 degrees. And notice also that these lines are parallel. That's what these arrows signify. So that means that this line here is parallel to this line, and we have a postulate we learned, the corresponding angles postulate. That tells you that if you have two parallel lines that are cut by a transversal, then corresponding angles are congruent. So what that means is if you look at this intersection area here, the upper left angle is going to be congruent to the upper left angle in the intersection area over here. All right, so those are congruent. And the upper right angle is congruent to the upper right angle over here. And the bottom left angle is congruent to the bottom left angle over here, and so on and so forth. So you can see the point. It's pretty easy. So if this bottom right angle is 93, then the bottom right angle over here must be 93 degrees also. So m must be equal to 93 degrees. Now, this angle here in red and this angle in blue, those form a linear pair. Now there are some students that have some problems with this. They're not quite sure why that's a linear pair. But the reason it's a linear pair is because they both have the same vertex, and they have a common side, which is this side here. And the non-included rays are going in opposite directions. Now that's just a fancy way of stating the obvious, and the obvious is that if you put these two angles together, the red and the blue, they make a straight line. So obviously the distance from here to here must be half of 360. It's 180 degrees. And that means they're supplementary. So that's the linear pair postulate. The linear pair postulate tells us that if two angles form a linear pair, which these do, then the angles are supplementary. So if they're supplementary, then that means that 93 plus A must be equal to 180, and A must be equal to 87 degrees if you subtract 93 from both sides. And I'm going to rectangle these. Now, if A is 87, then we can use the vertical angles theorem to say that x is equal to 87 also. There's a lot of different ways to do this, believe it or not. you can actually use the alternate exterior angle theorem, which says that that y is congruent to m. There's all kinds of different ways to do it, but the most important thing is you get the main point. It doesn't tell you in the problem that you have to write the actual theorem that you're using. Okay, so if x is 87, then by the corresponding angles postulate, d must be 37 or 87 also. So d is equal to 87 degrees. And A is 87, so the corresponding angle over here, C, must be 87 also. So C is 87 degrees. And what else do we need here? We need B. We know that Y is 93 and B is the corresponding angle because they're both the top left area in the intersection points. So B must be 93 degrees. And I think that's it. There's 1, 2, 3, 4, 5, 6, 7 variables, and we found 7 answers. So if you got those answers, good job. Okay, on to number 14. It says, find the distance between the squirrel and the acorn. Each unit on the grid represents 3 meters. So we need to find the distance between these 2 points. And a lot of students will say, I know how I can find the distance. I can just draw this line and then count the squares. Well, if you count the squares, you're going to find it's not so easy because that line is a diagonal. So this is a little more complicated than that. What we're going to do is we're going to use the distance formula. We're going to write the coordinates of the squirrel. It's 1, and then 1, 2, 3, 4. So 1, 4. And we have 1, 2, and then 1, so that's -2, -1. So -2, -1. So then we're going to find the distance. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now you might be thinking, wait a second, where did you get that formula? Well, we learned that formula in a previous class. I think the class was entitled The Distance Formula and the Midpoint Formula in 2 Dimensions. Are you going to have to memorize this formula? Yes. Unfortunately, you will have to memorize that formula. And I know what you're thinking. You're thinking, I don't want to do that, and I can't do that. You're going to have to do that because you're going to use this formula thousands and thousands and thousands of times in your math curriculum. So there's no avoiding it. You've got to memorize it right now. Okay, so I don't mean right now, I mean when you study for the test. So let's figure out what our points are going to be, and maybe we should have done that before. So let's write our points first. 1, 4, and -2, -1. And then I'm going to explain which point is which. So I'm going to call this point 1. So that's going to be x1, y1. And this is going to be point 2, x2, y2. It doesn't really matter which one is which, as long as you stay consistent once you determine which point is point 1 and which point is point 2. So now we're just going to plug in those values to the distance formula. So I want to be absolutely clear. I'm going to color these. So I'm going to plug that -1 in. Actually, the x2 is -2. Now we're going to subtract x1, which is 1. I don't really need parentheses there. So again, very, very important to understand where these numbers came from. You don't have to use colors. This is just for your benefit. y2, that's -1. Now we're subtracting y1, which is 4. Now I'm warning you, I'm giving you the strongest warning I can possibly give. sometimes you're going to deal with a double negative. In this problem, we did not have to deal with a double negative. Remember, when you're subtracting a negative number, sometimes you have to change it to a positive number. You need to do practice problems with this to make sure that you understand double negatives, because that's the biggest mistake that students make. If you were subtracting -1, then you would get -2 plus 1. So be very, very careful about that. You're probably going to encounter that in the practice test for homework. Okay, so the distance is equal to, and I want to color these, -2 minus 1 is -3, and -1 minus 4 is -5. Now I know what you're thinking. You're thinking, do we have to use these parentheses? Do we have to keep these there? And the answer is absolutely yes. If you write -3 squared and -5 squared like this, that's going to be completely wrong, because -3 squared is -9 and -5 squared is 25. So it's -9 minus 25. That's incorrect. There's no way that's the answer. You have to use parentheses. If you use parentheses, what happens is you get +9. Very, very different from -9, right? That's how math works. If you just change one little detail, then it throws the whole thing off. And if you're flying a space shuttle, or you're designing a car, you want the math to be correct. 9 plus 25 is 34. And the square root of 34, you can just leave it as square root 34, but that's not the answer, because it says that each unit on the grid represents 3 meters. So if there's square root 34 units and each unit is 3 meters, then we have to multiply that by 3. So the final distance is 3 square root 34. And we have to write m for meters. You must have your unit on there, so make sure to remember your unit. All right, so on to number 15. How much shorter will Casey's path be if he drives on the dirt road rather than the streets? So go and attempt this problem, and when you come back, we'll do it together. All right, we're back. So if Casey drives on the street, then the distance will be 8 kilometers for him to go from here to here, right? Then when he goes from here to here, it's going to be 15 kilometers. So the total distance that he's going to drive is 8 plus 15, which is equal to 23 kilometers. That's if he takes the street. But what if he takes the dirt road? So the dirt road, we have to figure out this distance. Now, usually roads are drawn with a 90-degree angle, so obviously that's a 90-degree angle. We can see that box in there. So that means that this is a right triangle, so we can find the length of the dirt road, or the distance from Casey to his destination on the dirt road with the Pythagorean theorem. So a squared plus b squared is equal to c squared. You can write 15 for a, or you can write 15 for b. It doesn't really matter. But what does matter is that the dirt road part is going to be c. So 15 squared is 225. You can use your calculator for that if you want to. 225 plus 64 that's going to be 289. And if we square root both sides, because we found the square of c. We found c squared, but we don't want c squared. We just want c. So you're going to have to get rid of that square. You're going to have to do the opposite of squaring, which is square rooting. And remember, always write a plus or minus. That's the biggest mistake that students make. And you can use your calculator for that. If you're using an iPhone, you're going to landscape your calculator on your iPhone, and you're going to see a button that looks like this. So what you want to do is you want to put 289 in, 289, enter that number, and then push this button, and you will get 17. So C is equal to plus or minus 17. But here's the thing. A length cannot be negative. There's no such thing as a negative length. So C must be equal to positive 17. All right. And I'm going to move that up a little bit. So the problem is asking how much shorter will Casey's path be if he drives on the dirt road rather than the streets. So we know that the dirt road is going to be 17 kilometers, and the paved road, the street, is 23 kilometers. So how much shorter will it be? I'm going to title this part of the problem shorter. It's going to be it's going to be 23 minus 17, which is equal to 6 kilometers, and that's all you really have to show for that problem. I would give you full credit for showing that alone. Sorry, this thing is just jumping all around for no reason. So for this part, I'm going to give a little bit more specific title. I'm going to say how much shorter. And that's a title for that part, so I'm going to capitalize those. So there you go, 6 kilometers. If you got that one right, good job. Okay, on to number 16. If you got that one right, good job. Find the midpoint between 6, -3 and -3, -2. So this is going to be an easy problem because we're just using the midpoint formula. So attempt that one, and when you come back, we'll do it together. All right, we're back. So the midpoint formula is the following formula. And so we're looking for the midpoint. So we're going to plug in the x values, 6 plus -3. And just to be clear, I got that 6 from there, and I got the -3 from there. Those are the x values, and we're dividing by 2. Then we're going to plug in the y values. That's the yellow and the purple one. So -3 plus -2 over 2. And so the midpoint, 6 plus -3 is 3. And -3 plus -2 is -5. There you go. And we just labeled those coordinates, or that point. We labeled the point as M. That's what it means when you put a letter right next to those coordinates. All right. So if you got that one right, good job. On to number 17. If the distance between 4,2 and 9y is root 74, find the possible values of y. Now this problem is very, very confusing. But notice that it says distance between 2 points. So that means we're going to use the distance formula. Our first point is 4,2. And our second point is 9y. And so I'm going to label these points x1, y1. That's going to be the first point, point number 1. And this is going to be point number 2, so x2, y2. I'm labeling y as y2. So now we're going to use the distance formula. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now again, I know what you're thinking. You're thinking, how in the world am I going to remember that formula? Well, you got to put in some effort. Your brain is capable of about 10,000 times more things than you realize. It's amazing what you can do when you have to. I think that was C.S. Lewis that said that. Okay, the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. But we also know d. We know the distance. They gave us the distance. They told us the distance between the 2 points is root 74. So I'm going to go ahead and plug that in. So just to be clear, the root 74 came from there. And this 9 we plugged in there. Again, you don't have to use colors. So we can simplify the right side of the equation a little bit. 9 minus 4 is 5. And then 5 squared is 25. So we have 25 plus y minus 2 squared. And now what we'd like to do at this point is get rid of the roots. We don't like roots. So we're going to get rid of those roots. In order to do that, we're going to have to square both sides. And I want to show the work. You don't have to show the work. You have to show some work, but you don't have to show all this work. I want you to show plugging in the values and showing some intermediate steps, because teachers are not going to believe that you did every single thing in your head. Even though you can do everything in your head, they don't want you to do everything. They want you to show at least some steps so that they know that you know how to do the problem. So now we're going to square both sides, because that's the opposite of square rooting. So that's going to get rid of the square roots. So then we have 74 is equal to 25 plus y minus 2 squared. And this is the part where a lot of students get sidetracked. What a lot of students do is they say, well, my instincts are telling me to go ahead and expand this out. Y minus 2 times y minus 2 using FOIL, so on and so forth. But that's actually going to go backwards. That's actually going to make the problem more difficult. So this is a problem where we have a square and we have to solve for the variable y. We learned how to solve equations with squares in my beginning algebra course, but it's been a while, so remember, you have to isolate the square first. So we're going to move this 25 on the other side because it's not isolated. The square is not by itself. The 25 is next to it. So we're going to subtract 25 from both sides, and we get 49 is equal to y minus 2 squared. And then we're going to, we can't get to the y because the square has it captured in there. So we have to get rid of that 2 power first. So we're going to rewrite the equation. And then we're going to square root both sides. And remember, when you do that, you have to write a plus or minus. One of the most common mistakes that students make is when they square root, they don't write a plus or minus symbol. So what number times itself is equal to 49? What number times itself is equal to 49? If you said 7, that's correct. And of course, that square root gets rid of the 2 power. And if you don't have the 2 power anymore, you don't need those parentheses. So now we're out of room, but that's okay. Don't panic if you're out of room. You can just use a line here. So we have plus or minus 7 is equal to y minus 2. So now we have to break this up into 2 equations. One equation is going to say positive 7 is equal to y minus 2. And the other equation is going to say negative 7 is equal to y minus 2. Now we're going to subtract or add 2 to both sides of this equation, and we get y is equal to 9. And we're going to add 2 to both sides of this equation to get negative 5 is equal to y. And those are the two solutions. So if the distance between 4, 2 and 9y is root 74, y can be 9 or it could be negative 5. And the reason for that is if you plot those points, 4, 2, let's say that that's out here, and the other point, 9y, that would be out here, somewhere out here. So it could be up here or it might be here. The coordinate, the x-coordinate is 9, but we don't know if y is going to be 9 up or negative 5 down, but either way the distance is going to be the same from here to here and here to here. So that's why there are two y values, the same x value but two different y values. Okay, so that was 17. On to number 18. Go ahead and try 18, and when you come back we'll do it together. Alright, we're back. So this line here is a perpendicular bisector. How do I know that? Well, because these two tick marks are the same, and this angle here is a box, which means it's a right angle, so that means it's perpendicular. So remember, we learned a theorem called the perpendicular bisector theorem, and that theorem tells us that if a point is on the perpendicular bisector of a segment, then that means that that point is equidistant from the ends of the segment. So that means that 3x minus 5 must be equal to x plus 75. The distances are equal. So subtract x from both sides, add 5 to both sides, divide both sides by 2, and we get 40. So the answer is 40. You write 40, you go on to the next problem, and this problem you get marked wrong. Why is 40 not the answer? 40 is not the answer because they're not looking for x. They're looking for BC. All right? So you have to use x to find BC, so don't be tricked by that. BC is equal to x plus 75, right? So we go on to the next step of the problem. BC is equal to x plus 75. We know x is 40, so we have 40 plus 75. So BC is equal to 115. And there are no units for this. So that's good enough. So if you got that one right, good job. All right, on to number 19. Go ahead and try 19. When you come back, we'll do it together. All right, we're back. So 56 is an interior angle of the triangle. 70 is an interior angle of the triangle. Y is an interior angle of the triangle. X is not an interior angle. X is called an exterior angle. When you continue a side out as a ray or a segment or something, this angle, which is supplementary to this interior angle, because it creates a linear pair, this angle is called an exterior angle. So we learned a theorem. It was one of the practice problems. I don't require you to remember this theorem, but it's called the exterior angle theorem. That says that this exterior angle is equal to the sum of the non-included sides, or non-included angles, that is. But you don't have to remember that theorem. There's another way to do it. So what we need to do here is very simple. We need to use the triangle sum theorem to find this angle. Remember, all the angles in a triangle add up to 180 degrees. Then once we find this angle, we can use the linear pair postulate. This angle plus this angle must be 180 because they form a straight line, right? This is a straight line. So let's find y. This is part 1 of the problem. So we're going to use the triangle sum theorem, 56 plus 70 plus y. Adding up all those angles, the measures must be equal to 180. 56 plus 70 is 126. And subtract 126 from both sides, and we get 54 for y. So the measure, and we have to write a degree symbol because that's the actual angle. So the measure of angle y is 54 degrees. So now that we know that, we can go on to part 2 of the problem. And maybe I should just write squiggly lines. That's probably good enough to separate the parts. We know that x plus y must be equal to 180, and we just figured out that y is 54. And again, they add up to 180 because it's a linear pair. Subtract 54 from both sides, and we get 126. That's exactly what we'd expect, because again, the exterior angle theorem tells us that the sum of the non-included angles are equal to the exterior angle. So if you got that one right, good job. Okay, on to number 20. Prove that the diagonals of the quadrilateral below bisect each other. So we can't do this problem unless we know what it means for two segments to bisect each other. In fact, that's probably the hardest part of the problem, is for students to understand exactly what that means. So what that means is, if you draw the diagonals, so this is one diagonal of the quadrilateral, and this is another diagonal of the quadrilateral. If you draw those diagonals, they cut each other in half when they cross. So what that means is that the midpoint of this diagonal is also the midpoint of this diagonal. So this point where they cross is the midpoint of both segments. And there's only one point where they cross, so they can only have one point in common. These two diagonals can only have one point in common. And if it turns out that that point is the midpoint of both of the diagonals, then that's what it means for the diagonals to bisect each other. So what we're going to do is we're going to find the midpoint between B and D, and that is going to be 3. Add the x values. I'm tired of writing parentheses, so I'm just going to write it in the abbreviated form. 3 minus 1 and over 2, and then the y values 4 plus 0 over 2. You know what, I probably should just use parentheses. And then, so the midpoint between B and D is equal to 2 over 2, comma 4 over 2. And simplifying that more, we get 1, comma 2. So that's the midpoint for that part of the problem. Now I'm going to use a squiggly line to separate. Now I'm going to find the midpoint between A and C. So I'm going to add the x values, negative 4 plus 6, and then divide by 2. That's the x value of the midpoint. And the y value is 2 plus 2 over 2. That's the y value of the midpoint. And you can go straight down. You don't really need an equal sign, but I'm just going to use one. So the midpoint between A and C, we're going to negative 4 plus 6 is 2, so we have 2 over 2. 2 plus 2 is 4, so we have 4 over 2. You don't have to show all this work. You can do this really quickly in your head. And then we have 1, 2, so the midpoints are the same. So I guess we could make a final statement. We don't really have to, but we could say the midpoint between B and D is equal to the midpoint between A and C. And it's not really mathematically correct to say a coordinate is equal to another coordinate, but that just shows you hopefully what's going on there. So we can say, therefore, AC bisects, or excuse me, we have to say AC and BD, and make sure you write your segments up there. They bisect each other. All right. So if you got that one right, good job. If you didn't know how to solve that, that's okay. So now we're going to go on to 21. Okay, show that the triangle below is isosceles. So an isosceles triangle is a triangle where two of the side lengths are congruent. So those two side lengths are going to be this length and this length. I know it's kind of hard to tell, but we can kind of see that because you're going up, you're going over 1, 2, 3, and then 1, 2, 3, 4, 5, and 1, 2, 3, and 1, 2, 3, 4, 5. So it's kind of the same triangle, but here the length is just going to be 1, 2, 3, 4, 5, 6. So that's kind of too easy. So we're going to find the distance between points A and B using the distance formula. So I'm going to make point B the second point, so x2 minus x1, and notice now we're going to have a double negative. That's the first time we've seen a double negative, I believe, today. And then y2 minus y1, and make sure you square those. So the distance between A and B is equal to the square root of what is negative 5 minus negative 2. That's just a double negative, so it changes it to a positive. And negative 3 minus 2 is negative 5. So the distance between A and B is equal to the square root of negative 5 plus 2 is negative 3. And please, please write your parentheses. Do not, whatever you do, do not write negative 3 squared. That is not correct. That's equal to negative 9. We don't want negative 9. If you square negative 3, you should get positive 9. It's negative 3 times negative 3, not negative 3 times 3. I know it's confusing. It can be very confusing. But you need to learn the language of mathematics, and that's one of the key problems. So now we have negative 3 times negative 3 is 9, and negative 5 times negative 5 is 25. So just by coincidence, we got root 34, which was a distance we found previously in a previous problem. So we found the distance between A and B, but now we have to find the distance between A and C and show that that's also root 34. So I'm going to make C 0.2 and A 0.1. So x2 is 1, and I'm going to subtract x1, which is negative 2. We have another double negative. And then I'm going to I'm going to take y2, which is negative 3, and subtract y1, which is 2. And so we have 1 minus negative 2 is 1 plus 2. Negative 3 minus 2 is negative 5. One plus 2 is 3. And negative 5 squared is 25. And then we get 3 squared is 9. You don't have to show every single one of these steps. You do have to show steps, but not every single one. And then we get root 34. So if you really wanted to, you could make a final statement saying that I don't really require you to do this, but you can say DAB is equal to DAC. Therefore, triangle ABC, or you could just say the triangle is isosceles. And I should rewrite that. Okay, so if you got that one right, good job. On to number 22. Now, we're going to do some two-column proofs. Notice it says you might not use the same number of steps written in Roman numerals. You may use more or less. So I have 4 steps for this problem, but you may decide to combine 2 of those steps into one, then you'd only need 3 steps. You might decide to take 1 step and break it into 2 steps. So this is just a suggestion for the number of steps that you'll need. Now remember, proofs are always intimidating, but if you just write the given information, which is in yellow here, write that down, get it on paper, at least that'll be a start. Don't complain until you write that down first. So go ahead and try number 22, and when you come back, we'll do it together. All right, we're back. So angle 1 is congruent to angle 3. That's the given information. And we have to prove that line M is parallel to line N. But all we know is that these 2 yellow angles are congruent. So what do we do from here? Well, isn't it true that we know that angle 1 is congruent to angle 2? Angle 1 is congruent to angle 2. That's the vertical angles theorem. Now, you shouldn't be surprised that we use the vertical angles theorem, because the problem actually told us to use the vertical angles theorem. See here in yellow? Now, if you don't remember what the vertical angles theorem is, then, well, that's a big problem. So you're going to have to get used to these theorems. Again, if you forgot, that's okay. It's okay to forget now. It's okay to forget when you do the second practice test for homework. It's not okay when you take the test. All right, so we know that angle 1 is congruent to angle 2 by the vertical angles theorem. So angle 3 is congruent to angle 1, and angle 2 is also congruent to angle 1. So angle 3 and angle 2 are both congruent to the same angle, so by the transitive property of congruence, those angles must be congruent to each other. And it doesn't really matter which way you write it. You could write angle 2 is congruent to angle 3. It's the same thing. So now we know that angle 3 is congruent to angle 2. But notice that those 2 angles, angle 3 and angle 2, are corresponding angles. Now, why are they corresponding angles? How do I know that? Well, if you look at this intersection area here, the bottom right angle is angle 2, right? If you look at this intersection over here, the bottom right angle is angle 3. So angle 2 and angle 3 are both bottom right angles in those intersection points. The intersection points being here and here. Bottom right, bottom right. So what that means is they're corresponding angles. We showed that angle 2 is congruent to angle 3. So that proves that line M is parallel to line N. And that is the corresponding angles converse postulate. So we learned the corresponding angles postulate, which says that if the lines are parallel, then the corresponding angles are congruent. We learned the alternate exterior angle theorem and the alternate interior angle theorem and the consecutive interior angle theorems. Those assume that the lines are parallel, but in this problem, we couldn't use any of those. We had to go in the backwards direction. Now, we had to use the corresponding angles converse postulate, which says that if corresponding angles are congruent, that proves that the lines are parallel. You see, whereas before we were, in the first 4 things we learned, we assumed that the lines are parallel. And so we had to use the converses, and because we showed that angle 3 is congruent to angle 2, the corresponding angle's converse postulate tells us that line M is parallel to line N. And what that means is if you have two alternate exterior angles that are congruent, that proves that the lines are parallel. So we proved the alternate exterior angles converse theorem, which tells us that that alternate exterior angles, if they're congruent, then the lines that the transversal cuts must be parallel. So if you had a little trouble with that, that's okay. You have plenty of practice problems. So now on to 23. Go ahead and try number 23. When you come back, we'll do it together. All right, we're back. So we'll start with angle E must be congruent to angle C. That's given. And we're told that B is the midpoint of AD. That's given. And because B is the midpoint of AD, that means that by definition, AB must be congruent to BD. That's just what it means to be the midpoint. Those two lengths have to be congruent. So that's the definition of midpoint. And if they're congruent, then that means that the lengths, well, I guess we don't need to go that far. So what else do we know here? We also know that this angle in orange here is congruent to this angle. How do we know that? You should know that by now. That's the vertical angles theorem. So I'm going to write vertical angles theorem. So that says that angle ABE must be congruent to angle CBD. Now I know what you're thinking. You're thinking, can't I just say angle B? Why do I have to say angle ABE? How come I can't just say angle B? Well, because angle B could be this angle, but it could also be this angle. It could also be this angle. It could also be this angle. And if that weren't bad enough, who knows, it might even be this angle. So we don't really know what you're talking about if you just say angle B. So let's just make sure we understand what we've done here. We've showed, because B is the midpoint of AD, we know that this length is equal to that length. They're congruent. And we know by the vertical angles theorem that these two angles are congruent. And we were told that this angle over here is congruent to this angle over here. So remember, we have 3 triangle congruence postulates and 1 theorem. And this is AAS, the AAS triangle congruence theorem. So we can now say that triangle ABE is congruent to triangle DBC. And it's very important to get the order of the letters correct in your triangle congruence statement. So let's go back over this. We were given the information that angle E is congruent to angle C. So look up at the picture and those orange arcs. So those angles are congruent, those orange arcs. We also know from the vertical angles theorem that these two angles are congruent, and we know that we showed that AB is congruent to BD. So if you start from this part of the triangle, that's an angle, so we say A, and then you go to the next corner, you have another angle, so we say A again, and then you go, again, following the order of the triangle, you go to the next part of the triangle that we have a congruence. That's a side, so it's AAS. And so is that a theorem? And the answer is yes, it is. In fact, that's the only theorem, not including the hypotenuse-leg theorem, that is an actual theorem. The other ones that we learned, the other triangle congruence statements are, or the triangle congruence tools that we learned were postulates. So that's AAS, and that also helps us with the order of the lettering. And of course, we know that now corresponding parts must be congruent. So if we start up here at A using alphabetical order, then we have to start at D. So look down here at the letters. We start at A, and we're going to D. Those are corresponding, and then the next letter is B, and C, and so on and so forth. So again, it's very important to write those letters in the proper order, or else your statement's not going to be correct. So now that we know that the triangles are congruent, we can say that all corresponding parts must be congruent. So that means that this side here, which we'll note is a double arc, that must be congruent to this side here. So again, you don't have to use all these colors. You don't have to explain it in detail. You just have to show your work and your proof and then go on to the next problem. So that is, we know that because corresponding parts of congruent triangles are congruent. So if the triangles are congruent, which we proved with the AAS theorem, then corresponding parts, all corresponding parts of the two triangles must be congruent. Therefore, this side must be congruent to this side because they're corresponding. So if you got that one right, good job. Okay, on to, we got two more problems here. So go ahead and try number 24. 24 is going to be a little harder. You're going to need the corresponding angles postulate and the linear pair postulate. So remember, before you complain, write down the given information. Q is parallel to N. We were given that. And we have to prove that angle 2 and angle 3 are supplementary. So this is a little bit harder than the previous proofs that we did. So we know that the lines are parallel, so we can use the corresponding angles postulate to say that corresponding angles are congruent. Angle 1 and angle 3 are congruent because they're corresponding. Why? This is the upper right region. This is the upper right region. If you look at the intersection points, again, if this is an intersection point and this is an intersection point, then the upper right angle is here, the upper right angle is there, so they're both corresponding angles. So we know that those two are corresponding, and now we have to use the linear pair postulate. We have to recognize that angle 1 and angle 2 form a linear pair. Now how do we know that? Well, we can just see looking at the picture. They're adjacent angles with rays, not included rays, going in the opposite direction. They make a straight line. So we can, that's given in the diagram. But the linear pair postulate tells us if they form a linear pair, then angle 1 and angle 2 are supplementary angles. So that's the linear pair postulate. And you can just write LPP if you want. That's fine. Now, if they're supplementary, then that means the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. That's just the definition of supplementary angles. Now, if angle 1 is congruent to angle 3, then we know that the measure of angle 1 is equal to the measure of angle 3. Again, you might do this in a different order. So now what we're going to do is we're going to take this equation here, this one, and we're going to rewrite it down here. But now I'm going to plug in measure of angle 3 for measure of angle 1. So let me show you exactly what happened there. I took this here and I turned it into that. And I did that because of the blue. I know that measure of angle 1 is equal to measure of angle 3, so I plugged that in. So measure of angle 3 and measure of angle 1, they add up to 180 degrees. And by the way, that is substitution. When you plug in, that's the substitution property of equality. And if measure of angle 3 and measure of angle 2 add up to 180, then by definition, angle 3 and angle 2 are supplementary angles. That's just the definition of supplementary angles. And you're going to have to rewrite that. Sorry. Angle 3 and angle 2 are supplementary. And that is just the definition of supplementary angles. And that's what we were trying to prove, right? So there you go. So that one was a more difficult problem, I know. But if you understand the linear pair postulate and all that type of stuff, then you're able to do it. Okay, so on to the last problem. Go ahead and try number 25. Remember, write the given information before you complain. So try 25. When you come back, we'll do it together. All right, we're back. So we're told that the measure of angle G is equal to 65 degrees, and the measure of angle H is equal to 65 degrees. That is given. We're also given that HI is equal to 2, but maybe we'll deal with that information later on. Okay, so if those two are equal, then that means that the measure of angle G is equal to the measure of angle H. If those angle measures are equal to the same thing, 65, then they must be equal to each other. That's the transitive property of equality. But of course what that means is that the angle G must be congruent to angle H by the definition of congruent angles. And I know it's very tedious having to write every single one of these steps, but that's just the way geometry works. That's the curriculum. So we proved that angle G is congruent to angle H. But if that's true, then we can use the isosceles triangle converse theorem, which tells us that if two angles in a triangle are congruent, then opposite sides must be congruent. So GI must be congruent to HI. But if that's true, that means that the length of GI must be equal to the length of HI. Now we're also told that the length of HI, segment HI, is equal to 2. That was actually given information. And by the way, that's the definition of congruent segments. So now at this point we're pretty much almost done. So we're trying to prove that GI is equal to 2. So GI is equal to HI, and 2 is also equal to HI. So GI and 2 are both equal to the same thing, which means that they must be equal to each other by the transitive property of equality. So we proved it. We proved that GI is equal to 2. So if you got that answer, good job. So that was the test today, the practice test. Let's go and take screenshots of everything that we did. You can use this test to help you with your homework or to study for test number 2. don't go before you get your homework. Let's take a look at the homework. So the homework is another practice test. So this is practice test version 2. So get screenshot number 1, screenshot number 2, and screenshot number 3, and screenshot number 4, and screenshot number 5, number 6, number 7, and number 8. But don't go before you get your answers. Remember, it's not enough just to attempt this test. Attempting the test is a waste of time. You need to check your answers and make sure that you did everything correctly. I want you to do the practice test correctly. Do you understand? Don't just write a bunch of nonsense on the test. So that's screenshot number 1 of the answers for the practice test and screenshot number 2. And remember, if you want to get an A or a B on the test, you not only have to do the practice test for homework, but you also have to go back and look at all the information that we learned to make sure that you have everything you need to get 90% of the problems correct, or 80%, or whatever grade you're looking for. So get that practice test done, and remember, in the next class we're going to take test number 2. Do not take that test in the next class unless you're ready for it. So I'll see you in the next class.